Hi guys, in this video I'm going to demonstrate the ability of Shellter to log thread context information. This information can then be later used in order for the user to build more dynamic and complex polymorphic code. In this video we will only see the ability of Shellter to keep track of that information. In the next videos we are going also to see how this information can be used. So I'm selecting the target and I'm going to log thread context. I'm not going to trace all the threads, just the main one, and I'm not going to show real-time tracing. So I'm going to let it to trace a few thousand instructions. Remember that we can always stop tracing by pressing Ctrl+C, but be careful if you press Ctrl+C in any other, let's say, stage of working with Shellter, you will just terminate Shellter. But however, during tracing you can use it in order just to stop the tracing and proceed. So let's just stop tracing. Just select the payload, just a simple not encoded shellcode advanced calculator. So in this case now we see that Shellter is going to ask if we want to prepend polymorphic code. Now we're going to say yes, and then we will say that basically we are going to use user polymorphic code. I mean, this means polymorphic code created by the user. So now we can use thread context information that has been logged. We have also a help option, so we say yes. Before doing so, Shellter will ask what is going to be the maximum size of the polymorphic code that the user wants to create. Okay, let's say in this case it's going to be 100 bytes. And then it's going to ask if we want to see only those entries where at least one of the general purpose registers logged points inside the portable executable in memory. This helps the user to know, for example, at which point at least one of the registers points inside the PE file, which means that it's more likely that this value will never change from one run and from one instance of the process and another instance. So we're going to say yes. We also have, by the way, a help option here which explains what it is. So let's say yes. And let Shellter filter those locations. We see there are quite a few. Okay, so if we select one of these listed instructions here, at least one of the logged general purpose registers will point inside the P file. For example, let's select 564 index. We see that we have two registers point inside the PE image in memory. We can also verify this. If I load this to Oli debugger, now remember that we used 564 is the address 406811. Let's just put a breakpoint here and run. So yes, let's just run. Let's now examine the values we saw before. So EBX, we see the value, and then ESI. Both these values point inside the executable. We can select to see another option if we want. For example, let's see this one. So we can load again. Let's go to that address. Set the breakpoint and run. So EBX, we see the value matches, and EDI, we see this value also matches. So a user is able to create a more complex polymorphic code that will take advantage of dynamic information that is generated in runtime. So it can create a more advanced self-decryptor, for example, that doesn't need to hard code the decryption keys. Now, in this video, we're not going to go into that detail, but I hope you had fun seeing this ability of Shellter to log dynamic threat context information. Thank you very much for watching.